right, in example 2, some of you will start to get excited. Not really. But we now have degrees. You like solving equations with numbers way better than fractions. Numbers, I should say, regular old 0 to 360 numbers. So, we're going to follow the same thing. We're going to deal with cosine now. Notice we've got everything out front that could happen. We've got everything possible here, and we have a vertical shift. This is everything that can happen to a sine and cosine graph. We're going to cover all of it. So, another weird thing that happened is, notice I have 3 pi minus 45. Okay? We're going to have to split this up. What? Yes, we're going to have to split this up. So the first thing that we're going to have to do is we're going to have to factor out the 3. Okay? Now, just to recap, all of this is still what follows the word cosine, not related to the vertical shift. But when I talk about a coefficient of x or theta, I think that's very clear that now when I determine my period, I can write down 0 to 2 pi divided by what? 3. But instead of 2 pi, what do I need to use? 360. So that's actually looking a lot better for some of you. 360 divided by 3 becomes 0 to what? 120. Yes, 120. I like that number, 120. Okay? Now, here's the key idea with this. This does not mean my graph starts at 0 and goes to 120. That's what you learned yesterday when we were introducing the concept. But what it means is that from start to finish, my graph occupies 120 total degrees, wherever it's located left to right. So keep that in mind. 120 degrees is how much of the graph it takes up, how big it is. What's my horizontal asymptote? Y equals 2. What's at the end? Amplitude? 3. All right, but don't forget we're going to have the flip of the graph because it's a negative. If you wrote -3 here, I wouldn't mark that wrong. Okay? The -3 would incorporate the fact that you were doing the flip. Now we need to determine the phase shift. What were the 5 key values of cosine in degrees? It started at 0 and it went to what? Originally 360. Okay? So again, I want to reiterate, use the 5 original key values. Don't relate it back to the period. Go back to the 5 original. So in between I have 180, 90, and 270. What do all 5 of those get set equal to? Whatever follows the trig function, not related to the vertical shift. Okay, now, this is a key, this is going to make your life easier, in my opinion. I always use the original form. I like solving equations like that. So I would say 3 theta minus 45. Can you solve that in your head? Add 45 and divide by 3. What do you get? What's theta equal to? In your head? Add 45 to the right and divide by 3. Thank you. 15 is my new starting point. Okay, same thing. 3 theta minus 45 is equal to 90. What do you get? Add 45, divide by 3. Right? What's 135 divided by 3? It's a weird one, but it's a decimal. You have calculators. You can use them. What is 135 divided by 3? 43 even? Can you just leave it on the desk there? Okay. 45? 45? All right, what about 180? starting to sense a pattern here. $105, yep, that's right. Next one. $135. So now I can answer the question about the phase shift. It's going to start at 15 and it's going to go to 135. Now if you subtract those, does that agree with what you found for the period? 120 degrees. Yes. So there's a quick check to make sure these two things match. So I'm going to start at 15 degrees so I can make that up. 15 here. Let's go out here for 135. Let's make this evenly spaced. There's my values. Where's my center line located? This guy right here. It's now at +2. And my amplitude, you told me, was 3 up. So I'm going to go 1, 2, 3, 1, 2, 3. That's going to take me down to -1 and all the way up to 5. How many key points does cosine have? 2, but remember, there are always this number 2 and the number 4 spot. So I'm going to be at 45. I'm going to be at 105. I normally would count up 1 for amplitude, but with a -3, I'm going to count down 1, 2, 3. In the middle, 1, 2, 3. At the end, 1, 2, 3. And I'm going to make my very pretty mouth.